Math 110, Probability, Section 8.8. Now we're going to be learning about two types of probability. The first is going to be experimental probability. Now let's just say if I tossed a coin 100 times and 57 of them were heads, I would say that 57 out of 100 were heads, or 0.57. Now in this scenario, it's experimental determination of that probability. Now, such a determination of probability is discovered by the observation and study of data and is quite common and it's useful. Now, to give a few examples of that, 60% of all college freshmen entering a four-year college graduate in 6 years. The probability that a woman is going to be diagnosed with breast cancer in her life is 1 out of 8, and anyone who reaches the age of 65 has a 40% chance of entering a nursing home during the remainder of their life. Now, if we consider that same probability falling on heads, the theoretical probability is going to be 1/2 or 50%. And so there's our contrast of experimental and theoretical, which is the second type of probability. If there are 30 people in a room, the probability that 2 of them have the same birthday is 0.706%. While on a trip, you meet someone and after a period of conversation discover that you have a common acquaintance. The typical reaction is "it's a small world" is actually not appropriate because the probability of such an occurrence is quite high. It's over 22%. So computing experimental probability, given that an experiment in which n observations are made, if a situation or event E occurs, so the probability of event E, m times out of n observations, then we say that the experimental probability of the event, P of E, is given by m over n. So our first example, it says there are estimated 114,200,000 households in the United States that have at least one television. Each week, viewing information is collected and reported. 1 week, about 28 million households turned into the 2013 Grammy Awards, and about 14 million households turned into the action series NCIS on CBS. What is the probability that a television household tuned into the Grammy Award ceremony during the given week and to NCIS? So since we're doing experimental probability, we take this value and divide it by how many observations there are. So P of E equals m over n. And so the probability for the Grammys is going to be that 28.51 million divided by the 114.2 million, and that gives me approximately 24.96%. The probability of NCIS is 14,204,000 out of that same 114,200,000, and that's going to be approximately 12.44%. Example number 2, it says the Jedi Academy conducted an experimental survey to determine how many Jedi are left-handed, right-handed, or both. The results are shown in the graph at the left. The Academy surveyed 100 people. So it's asking us to do these 4 things. The first, determine the probability that the person is right-handed. So there's going to be a total of 100 observations, and 82 were going to be right-handed, so I'm going to say the probability is going to be 82 out of 100. B, it says determine the probability that a person is left-handed, so I'm going to say 17 out of 100. C, it says determine the probability that a person is ambidextrous, so that's going to be 1 out of 100. And then D, it says there are 120 new knights that just passed the trials. Based on the data, how many can we expect to be left-handed? So because I said that 17 out of 100 were going to be left from our little study that we did, I can assume that that same 17% of that 120 are also going to be left-handed. It allows us to draw that type of conclusion, regardless if it's accurate or not. And so I can take that 0.17, multiply it by the 120, and you would get between 20 and 21 new Jedi are going to be left-handed. Now with theoretical probability, we're going to do some definitions. Each possible result in an experiment is called an outcome. The set of all the possible outcomes is called the sample space. An event is the set of all outcomes that is a subset of the sample space. So consider the dartboard to the left. Assume that the experiment is throwing a dart and that the dart hits the board. Find each of the following, the outcomes and the sample space. So I could either hit the gray area, I can either hit the green, or I can hit the orange. And so my outcomes are going to be that gray, the green, and the orange. Now the sample space is going to be all of them, like considered simultaneously, gray, green, or orange. Suppose that an 8-sided dice was rolled. What are the outcomes in sample space? So the outcomes, I can roll a 1, 2, 3, 4, 5, 6, 7, or 8. Now the sample space is going to be the set of all those considered at the same time. Now when we're computing theoretical probabilities, it's going to be very, very similar to the experimental probabilities. If an event E can occur m ways out of n possible equally likely outcomes of a sample space S, so just remember that every single thing is going to be equally likely to occur, then the theoretical probabilities of the event P of E is given by P of E equals m over n. Basically, what is it asking divided by the total, or the sample space, however you want to think about it. So suppose that we select, without looking, 1 marble from a bag containing 3 red marbles and 4 green marbles. What is the probability of selecting a red marble? So the n equally likely outcomes are 7 because we have 3 marbles and 4 marbles. So added those together, you get 7. Now the m ways to get it is 3. Those are the red marbles that it's looking for. So the probability of selecting a red marble is 3 out of 7. What it's asking out of the total. What is the probability of rolling an even number on a 6-sided dice? So the n equally likely outcomes are 6. 1, 2, 3, 4, 5, or 6. Now the m ways to get it is going to be 3 because I only have 2, 4, and 6. So the probability of rolling an even number is going to be 3 out of 6, or 1/2. Number 7 says, what is the probability of drawing an ace from a well-shuffled deck of cards? The n equally likely outcomes are 52 because there are 52 cards in a deck. The m ways to get it is 4 because there are 4 aces in a deck. So the probability of drawing an ace is going to be 4 out of 52, which is the same as 1 out of 13. So a few probability properties. If an event E cannot occur, then we're going to say the probability of that event is automatically 0. So for example, if I was rolling a dice, a 6-sided dice, and I asked what's the probability of rolling a 7, you'd say it's 0. It's impossible. If an event E is certain to occur, then we're going to say that the probability of that is 1. So if I had a spinner and the entire region was red, and I said flick the spinner, what's the chance of it landing on red? You're going to say it's 1 because it has a 100% chance of hitting it. And we can also assume that always our probability is going to be a number from 0 to 1. You're never going to get a negative probability. You're never going to get a probability that's going to be greater than 1. Example number 8, it says, suppose that 2 cards are drawn from a well-shuffled deck of cards. What is the probability that both of them are spades? So now we're getting into the realm of combinations. And the reason is because we're looking at all of the combinations of taking 2 cards that are going to be spades. And so the way that we need to think about it is drawing 2 random cards from a deck of cards is going to be 52 choose 2. So we're thinking about every single possibility of just grabbing 2 cards. Now, because there are 13 spades in a deck of cards, and we want 2 drawn to be spades, we're going to say it's going to be 13 choose 2. This is what we want. Out of those 13 spades, I want both of them to be spades. And so setting this up, it's going to be 13 choose 2 over 52 choose 2, which is 78 over 1,326, which is 1 out of 17. Example number 9, it says, suppose that 3 people are selected at random from a group that consists of 6 men and 4 women. What is the probability that 1 man and 2 women are selected? So I have a total of 10 people. From the 6 men, I'm choosing 1. From the 4 women, I'm choosing 2. So the total number of ways of selecting 3 people is going to be 10 choose 3. Because I'm taking the 10 people and I'm choosing 3 of them, and it's just all at random. Now 1 man can be selected in 6 choose 1 ways, and selecting 2 women can be 4 choose 2 ways. Now the relationship between these two numbers, if we go back to our counting principles, we're going to be multiplying them together. And so the probability is going to be 6 choose 1 times 4 choose 2 divided by 10 choose 3. And then if you simplify that, you're going to get 3 out of 10. Now it says, what is the probability of getting a total of 8 on rolling a pair of 6-sided dice? Now we're not talking about independent events, and so that actually allows us to be able to solve this problem a little bit easier. But the way that we're going to have to think about it is we're going to have to kind of like draw a map. And this map is going to say, what are all the different possibilities of one dice compared to the other? So for example, I can roll a 1 and a 1, which means my total's a 2. I can roll a 1 and a 2, which means my total's a 3. I can roll a 1 and then a 3, which means my total's a 4. I can roll a 1 and a 4, which means my total's a 5, and so on and so forth. Now, if you create this map, you're going to notice that there's going to be a 6 by 6 selection, or a total of 36. And so you just need to look on here and see, hey, which of these selections are going to give me 8? This highlighted region are going to be those selections, and there's 1, 2, 3, 4, 5. So that's going to be 5 out of 36 selections.